Welcome to week 7 for Math 120. I just wanted to talk about a couple of really important ideas from chapter 6 today and kind of demonstrate them again, even though you have an online lesson, some videos to look at. Just want to touch on them a little bit differently. So I have in my hand, if you can hear that, I have 10 coins in my hand. A variety of different ones. I've got a quarter, 2 dimes, 3 nickels, and 4 pennies. So let's say I draw a coin at random from my hand. So kind of like shake them up and draw a coin. It is a nickel. So the value of this coin is 5 cents. So let's put it back, shake them up again, shake them, and pull out, quarter this time, 25 cents, quarter. And shake them up again, draw one. What did I get? It is a dirty penny, old penny. And I could repeat doing that. I could do this over and over and over again, and the value of the coin that I draw would vary between 1 cent, 5 cents, 10 cents, and 25 cents. And so you might wonder, okay, over the long run, what would be my average? What would be the average value of the coin that I would get? And so what we do is we have those 4 values and we just weight them by their probability. So we said we had 4 pennies, so that's 4 out of 10. So the likelihood of a penny is 0.4. And so we just multiply that by its corresponding value. And so we'd weight that corresponding value. Same thing for the nickel. We've got 3 of those, and so their probability is 3 out of 10, 0.3. So we multiply that by its probability. Same thing for the dime and the penny, so the dime and the quarter. And so when we're done, we add all that up, we get 6.4 cents. So that is called the expected value. Now that's not to say, well, if I draw a coin at random, I can expect it to value 6.4 cents, because it can't. It's either a penny, a nickel, a dime, or a quarter. What the expected value means is if we repeat this over and over and over and over and over and over and over again, our long-term average will be 6.4 cents for the value. That's expected value. All right, the second thing I want to talk about is binomial probability. So I've got one of those coins here. I have a penny here in my hand. And so let's say I want to flip it 5 times, and I want to count the number of heads. So we'll flip it once, tails. Flip it again, tails again, flip it again, tails again, and whoa, whoa, whoa. Heads on that one, and one last one, heads on that one as well. So we had 1, 2, 3 tails, heads, heads. So if I'm counting the number of heads, that's 2. I got 2 heads that time. And so if I want to look at the broad probability, what's the probability of getting 2 heads? One might look at this and say, well, the probability of a head is 1/2. Probability, the first one was a tail, right? Probability of a tail is 1/2, tails 1/2, tails 1/2, head also 1/2, head 1/2. So the probability of 2 heads would be 1/2 to the 5th. The problem is that my 2 heads happen to be the last 2, but they could have been the first 2, or the first and the third, or the second and the fourth. So in fact, there are 5 choose 2, because order doesn't matter. 5 choose 2, the combination of 2 from 5 ways, which is 10 different ways to get 2 heads. And so my probability is actually 10 times the probability of a head, which is 1/2 twice, so 1/2 squared, times the probability of a tail, which is 1/2 cubed, because I had 3 tails. That gives me my end probability, 0.3125. So probability of about 0.31. So it happens about a third of the time I would get 2 heads out of the 5. So binomial probability basically is saying, if I want to find the probability of X successes, what I would do then is take the probability of X successes, that is the number of ways to get that X number of successes, times the probability of that success raised to however many successes you're looking at, times the probability of it not happening to the number of times it doesn't happen. Or more generally, the probability of X is the number of combinations, NCX, then times the probability p to the x, and then the probability of it not happening is 1 minus p, and then the exponent there is n minus x on that one. And that's the binomial probability. So if we think of a histogram of this probability, we're not going to connect them because they're really disjoint events. So we have the possible outcomes along the horizontal, and then the vertical would be the probability. And so we have 0, 1, 2, 3, 4, 5 for our possible values for x. We could have no heads, one heads, etc., up to 5. And so if we use the binomial probability, we get, I think it's like 0.05 for the first, for if you have none, and then 1, 2, 3, 4, 5, etc., there are corresponding probabilities. And so if I wanted to find the probability of getting 3 or less heads, it would be the probability that x is less than or equal to 3, then I would just look at those 4 probabilities and add them together. The nice thing is for us, we have StatCrunch that can do this for us. It's under the stat menu, there's a calculator, you go stat calculator binomial, and then in there you can enter your n, your number of trials, which is 5 here, your your probability of success, which is 0.5 if our coin is fair, and if I'm flipping it in a fair manner, and then the number of successes. And you can do a less than or equal to, you can do it equal to, you can do a greater than, and that's all within the binomial calculator in StatCrunch. So that is binomial probability, and that is in section 6.2.